How's everybody doing? Mr. Alfonso. Want to continue and finish up this semester. I know this is going to be a little different for everybody, including myself. Everybody's gotten used to the one-on-one during class, but as I'll get into in a second, we have to be adaptable. First safety message, obviously around coronavirus. I hope all of you have seen this. Hope you're all practicing these items. And one of these days we're going to get through this and be, in my opinion, a better country because of it. So what to expect the remainder of the semester? All communication is going to have to be by email. There's no other way around this. So I'm going to make it as simple as possible for both ends. And so if you have questions moving forward, I'm probably not going to be on my email every day, but I will, just like in the past, I'll respond to you in a timely manner. I'm going to leave this open-ended as far as the structure. I know most of you like to put off things to the last minute, and I think you should probably work on this a little bit as we move along over the next month. Here's a perfect example of me teaching real world experience, and everybody right now needs to be flexible and adaptable, correct? Including yourself. So what's happening out there in the real world? I've had multiple discussions with some people I used to work with, and they are scurrying right now to keep things going. Designers are taking their entire workstations home to try to continue work they're doing at home. Project managers are trying to work at a distance, which is literally impossible because face-to-face and meetings are probably the best thing. And every job, including probably your families being asked to work from home or not working at all, you can see the impact on a lot of these things. So how does this affect you? We have to be adaptable. We have to be flexible too. And to continue with this class, this is one way of doing it. So we're going to get into what I'll term as the spring project and the final project. We'll also post this on Blackboard for you so you can look at it in a little more detail. So what are we going to do? We're going to design a transport skid to protect this product that I have. It's an 8-foot diameter tank, 14-foot long. It's going to be protected during transport, in this case from Hong Kong to Los Angeles. So here's the scope. 120 skids are needed. All right? They need to be stackable. They need to be stacked one on top of another, like you see on those transport ships of sea vans. They need to be transported by truck to and from the port. All right? So they need to be lifted onto the truck. They need to be lifted off of the truck. And the shipper needs the overall size, how much space these 120 skids are going to take up. Along with this, the overall cost is going to be provided by you, along with the weight of each skid. So a bill of material is going to be needed. All right? Again, I will post this on Blackboard so you can look at it in more detail. So what's this going to look like? It's going to need lifting lugs. What are lifting lugs? They're going to be lugs in order for a crane to pick this up. Maybe forklifts, slots for forklifts. So this can be picked off the ground and onto the truck. So the bottom skids, what I mean by the bottom skids, the skids that'll be on the bottom of the deck of the ship. Those skids will be the heaviest weight on top of them. Those skids will be 10 by 10 I-beams. The middle skids, the middle layer of skids, is going to be an 8 by 8 I-beam. And the top skids will be a 6 by 6 I-beam. So what you need to do, you need to take that tank that was in the previous slide here, which is 8 foot long or 14 foot long, 8 foot in diameter. You basically need to build a box around it and come up with a way to support it for transportation. So you need to hold the tank in place during shipment, but at the same time it needs to be easy to remove once this tank is at its destination. So if you want to, for example, put plates along here where they're bolted, where you can take the top off, lift the tank out, and at the end all the steel will be scrapped once the transport is complete. Now you haven't even started with a drawing yet, but you have all the scope for the project. You have basically what you might see in corporate America as they give you the directions of what they want. So you have a blank slate. You can start using your mind as a designer to design this. So where do I start? What information do I have? Let's recap this. You're going to design a transport skid to protect this tank. It's really immaterial where it's going. It's going to go on a boat. It could go from, all it's got to go is from point A to point B. It's got to be lifted onto a truck, from a truck onto the boat, from a boat back onto a truck, from a truck to wherever it's going. It's got to be unloaded, and this encasement has to be easy enough to remove for the tank to be taken out, and then the steel will be scrapped. So the only thing that is needed is this encasement for the tank. You need to design it. So what's the scope? 120 of these skids are needed. Again, they need to be stackable. They need to be transported. The shipper needs how much space it's going to take up on the boat. This needs to be taken into consideration. What is this? It's the stupid triangle. So you need to come up with how much this space is going to take up. I gave you the size of what these skids will be made out of, I-beams. The bottom layer needs to be 10 by 10. The middle layer 8 by 8. The top skid's 6 by 6. Do you think that might take into consideration you thinking about the stupid triangle? At a later time, I will give you the cost of how much this steel is per foot. And you need to create a BM, which will be basically how much steel is going to be used to build all these with these sizes. So what's your deliverable? An issued for construction drawing of each of the transport skids. I want one drawing for each size. You need to design a support to hold the vessel for shipment and be easy to remove once it arrives at the destination. Lay out how they would be lifted onto the flatbed. Lay out how they would be lifted onto the ship. Bill of material for the entire project. And the cost of the project, including material, labor, and shipping. I'll give you the cost per foot of steel, etc. at a future date. Again, I will post all these slides on Blackboard. So where are we at? Basically only have 5, 6 classes left. Final is going to be right now, and unless things change, the 4th is the day these drawings, the BM, etc. are going to be due. You basically have a month to finish this. This is your final project. I will probably have an updated lecture on the 6th giving you the cost of material. I will collect all questions that you email me and give you an update to point you in the right direction on the 6th. And this should give you enough time to finish this drawing and all appropriate information that supports it on the 4th of May. Again, here's the scope. This is kind of what I want it to look like. All right. I know you'll have questions. Going back to the original slide, we all need to be adaptable. We all need to be flexible. This is real world stuff. This is probably how a bunch of corporations are operating right now to make real things, to keep projects going, to keep the stupid triangle in equal quadrants. Email me if you have questions. We'll work through this together. But most importantly, be safe. Take care of each other. I'll talk to you soon.